October 4th, 1957. The date when humanity supposedly took its first tentative step into the cosmic arena. That persistent beep from Sputnik 1 didn't just announce the dawn of the space age, it marked what the textbooks tell us was the moment when artificial objects first began orbiting our planet. Before that date, we've always been told, the night sky was a pristine celestial sphere, empty of human technology, populated only by the ancient dance of stars, planets, and wandering comets. But what if the textbooks were wrong? What if something was already up there, watching, waiting, reflecting sunlight back to Earth years before humanity had officially entered space? Hidden in the archives of California's Palomar Observatory lies evidence that challenges everything we thought we knew about when humanity's presence first extended beyond Earth's atmosphere. Before we explore what this could mean for humanity, take a moment to subscribe to the channel, but only if you genuinely enjoy what I do here. I'd also love to hear from you in the comments. Tell me where you're listening from and what time it is in your part of the world. Now, prepare yourselves. We begin. Part 1. The Enigma of the Ghost Satellites. Between 1949 and 1958, astronomers of California's Palomar Observatory undertook one of the most ambitious projects in the history of sky surveying. The first Palomar Observatory Sky Survey, known to researchers as POS-1. This wasn't just another mapping project. They were creating a definitive photographic atlas of the northern night sky, one painstakingly exposed glass plate at a time. Each observation required enormous patience and precision, exposures lasting 40 to 50 minutes, long enough to capture the faintest whispers of light from the most distant galaxies. The technology was elegantly simple, yet extraordinarily demanding. Large glass plates coated in silver emulsion, carefully exposed night after night to build an irreplaceable record of the heavens as they existed in the decade before Sputnik's historic launch. Today, those plates represent something extraordinary, a time capsule of the pre-space age sky. They preserve a view of the cosmos untainted by the thousands of satellites and millions of pieces of debris that now clutter near Earth space. It's like having a photograph of Manhattan before the first electric light was installed, a pristine baseline against which all future change can be measured. Dr. Beatrice Villaruel, an astrophysicist at the Nordic Institute for Theoretical Physics, recognized the unique scientific value of this historical dataset. As the lead investigator of the vanishing and appearing sources during a Century of Observations project, mercifully shortened to VASCO, she and her colleagues embarked on a systematic comparison between these vintage plates and modern digital sky surveys. Their initial goal seemed straightforward: identify celestial objects that had either appeared or vanished over the intervening 70 years. Such discoveries could reveal extreme astrophysical events, perhaps a star's final death throes, the birth of a new cosmic phenomenon, or the sudden brightening of a previously invisible distant galaxy. What they found instead was something that shouldn't have existed at all. The team developed rigorous criteria for what they would call transients, distinct star-like point sources that appear in a single POS-1 red plate but are completely absent in the plate taken just before and in all subsequent images of the same sky region. These weren't the familiar streaks left by meteors blazing through the atmosphere, nor were they the predictable brightening and dimming cycles of variable stars. Instead, they behaved as if someone had briefly switched on a celestial light bulb, held it perfectly steady relative to the background stars for the duration of the exposure, then switched it off again. The scale of the discovery was staggering. Dr. Villarol's colleague, Enrique Solano, developed sophisticated automated workflows to scan the digitized plates, hunting for these mysterious transients among hundreds of thousands of potential candidates. Their initial automated search produced a catalogue of 107,875 transient detections spanning the years 1949 through 1957. But automation could only take them so far. The crucial task of visual inspection and classification fell to an international network of citizen scientists, volunteers who became digital archaeologists, sifting through decades of astronomical data in search of the impossible. These dedicated individuals helped verify, classify, and analyze the most promising candidates, turning what might have been an insurmountable data processing challenge into a collaborative scientific investigation. Among the thousands of candidates that emerged, certain events stood out with particular clarity and significance. On July 19, 1952, a POS-1 red plate captured what would become known as the triple transient, three bright, point-like objects that appeared together in perfect formation. When astronomers examined the blue exposure taken immediately afterward, the objects had vanished completely. When they checked plates of the same region taken 2 months later, there was no trace that these objects had ever existed. Even more remarkable was an earlier discovery that would anchor the phenomenon historically well before Sputnik. On April 12, 1950, a single photographic plate revealed 9 simultaneous point sources appearing together in a small region of sky. Published in Scientific Reports in 2021, this finding demonstrated that whatever was creating these transients had been active at least 7 years before humanity's official entry into space. The physics of these observations proved as puzzling as their existence. On 40 to 50-minute tracked exposures, genuine stars appear slightly blurred due to atmospheric seeing, telescope vibrations, and minor tracking errors that accumulate over the long observation period. But the transients appeared as sharp, perfectly circular point sources, exactly what optical physics would predict for a sub-second flash of light that was too brief to be affected by these cumulative blurring effects. This crucial detail would later become central to debates about the nature of these objects. The sharp, circular appearance wasn't evidence against their reality. It was exactly what you'd expect from genuine brief flashes of reflected light. Perhaps most intriguingly, the point-like, stationary appearance of these objects during long exposures suggested they were located at enormous distances from Earth. The geometry indicated altitudes potentially near geosynchronous orbit, 35,700 kilometers above the equator, where modern communications satellites hang motionless over single points on Earth's surface by matching their orbital period to our planet's rotation. This was the detail that transformed curiosity into genuine scientific crisis. Geosynchronous orbit is the exclusive domain of advanced satellite technology, a concept that wouldn't be practically implemented until the 1960s. Yet here were objects apparently occupying these orbits years before Sputnik had even been conceived. The Vasco team maintained a refreshingly transparent approach to their extraordinary findings. They made their data processing pipelines and source code publicly available, inviting replication and independent verification. Their method-first philosophy emphasized rigorous testing protocols designed to separate genuine astronomical phenomena from photographic artifacts, a critical distinction that would soon prove essential to understanding what they had discovered. As the evidence mounted and the implications became clear, the central question evolved from a simple search for variable stars into something far more profound. If some portion of these transient events represented real, reflective objects in high Earth orbit, how could researchers prove definitively that they obeyed celestial physical laws rather than representing random emulsion flaws on 70-year-old glass plates? The answer would require one of the most ingenious tests in the history of observational astronomy, a test that would use the Earth itself as a cosmic filter to separate genuine orbital phenomena from photographic noise. The stage was set for a confrontation between the impossible and the undeniable, with the shadow of our own planet serving as the ultimate arbiter of truth. Part 2. The Shadow Test. A glint in the darkness. The burden of proof in science is relentless and unforgiving. When you claim to have discovered something that fundamentally shouldn't exist, every possible mundane explanation must be systematically examined and eliminated before anyone will take your findings seriously. The critics of the Palomar transient discoveries had reasonable ammunition in their arsenal. Old photographic plates are notoriously imperfect creatures, subject to scratches, chemical deterioration, and contamination from the radioactive fallout that filled the atmosphere during the height of atomic testing. Throughout the 1950s, atmospheric nuclear weapons tests were releasing radioactive particles that film manufacturers like Kodak knew could create false images on sensitive photographic emulsion. Cosmic rays constantly bombarded the plates from space, creating tiny tracks and spots that could potentially mimic astronomical point sources. Random chemical flaws in the silver emulsion, microscopic scratches from handling, and even contamination during the digitization process decades later could all theoretically produce point-like artifacts that might fool sophisticated detection algorithms. Dr. Villarreal and her team needed something more powerful than statistical arguments. They needed a definitive test that could cleanly separate genuine astronomical phenomena from photographic noise. Their solution was as elegant as it was ingenious. They would use Earth's shadow as a cosmic filter to distinguish between real orbital objects and random plate defects. The concept builds on a simple but profound astronomical reality. Just as our planet casts a shadow on the Moon during a lunar eclipse, it projects a long, conical shadow, known as the umbra, deep into space. Any object orbiting Earth must periodically pass through this region of absolute darkness, where direct sunlight is completely blocked by our planet's bulk. This principle is beautifully demonstrated by the International Space Station during its regular passages across the night sky. Watch the ISS traverse the heavens, and you'll see it shine like a brilliant moving star, reflecting sunlight off its solar panels and metallic surfaces. But the moment it crosses Earth's terminator line, the boundary between day and night, it doesn't gradually fade or dim. Instead, it vanishes instantly, snuffed out as completely as if someone had thrown a switch. The sunlight that makes it visible is suddenly and completely blocked by Earth's bulk, and the station disappears from view until it emerges from the shadow on the other side of its orbit. This observable phenomenon gave the Vasco team their crucial insight and their most powerful test. If the Palomar transients were caused by sunlight reflecting off physical objects in space, if they were genuine glints from orbiting hardware, then they should behave exactly like the ISS. They should be completely invisible when positioned inside Earth's shadow during the photographic exposures. Conversely, if the transients were self-luminous phenomena like brief stellar flares, or if they were merely artifacts created by flaws in the photographic plates themselves, their distribution across the sky should be entirely random. They should show no statistical correlation whatsoever with the position of Earth's shadow. As Dr. Villarreal put it with characteristic scientific precision, plate defects don't know where the shadow is. This insight created a clean, testable prediction that could definitively differentiate between competing explanations. The Umbra test would either validate the most extraordinary interpretation of the data or demolish it entirely. The methodology required extraordinary computational effort and astronomical precision. For each of the hundreds of thousands of transient candidates in the Vasco database, the team had to calculate the exact location and geometry of Earth's shadow at the precise time and date when each photographic plate was exposed. This wasn't a simple matter of drawing circles on sky charts. It required accounting for Earth's orbital position around the Sun, the exact timing of each exposure, the geographic location of Palomar Observatory, and the specific altitudes where objects might be orbiting. They focused their analysis primarily on altitudes consistent with geosynchronous orbits around 42,000 kilometers from Earth's center, where the shadow geometry is well defined and predictable. At these distances, Earth's umbra creates a cone-shaped region of darkness that sweeps through space as our planet rotates, and any reflective object entering this zone would immediately become invisible to ground-based observers. The computational challenge was immense. Earth's shadow moves continuously across the sky throughout the night as our planet rotates, and its exact position must be calculated separately for each individual photographic exposure. The team had to account for the non-uniform coverage of the sky survey, the varying exposure times of different plates, and the complex geometry of how the shadow projects against the distant stellar background. The first results of this analysis were nothing short of staggering. In their initial brute force calculation, the team estimated the total fraction of sky covered by Earth's shadow across all the photographic plates in their survey, then compared this expected coverage with the actual number of transients found within those shadowed regions. The result showed a deficit of transients in the shadow with a statistical significance of 22 sigma. To put this extraordinary figure in perspective, consider that the gold standard for claiming a discovery in particle physics, such as the detection of the Higgs boson at CERN, is 5 sigma. A 5 sigma result means there's roughly a 1 in 3.5 million chance that the observed effect is due to random statistical fluctuation. A 22 sigma result means the probability of this occurring by pure chance is so vanishingly small that it essentially doesn't exist in any meaningful sense. The magnitude of this statistical significance was so overwhelming that the team suspected they might have made a computational error or introduced some systematic bias in their analysis. To verify their extraordinary finding, they performed a more conservative and refined analysis, calculating the exact percentage of each individual photographic plate that was covered by Earth's shadow during its specific exposure time, rather than using generalized sky fraction estimates. This plate-by-plate approach accounted for the non-uniform coverage of the sky by the POS-1 survey and eliminated potential biases from plates that might have been taken during periods when the shadow covered unusually large or small portions of the sky. When they compared this more precise expectation with the observed data, the result remained undeniable, though somewhat reduced from their initial calculation. The deficit of transients in Earth's shadow was confirmed with statistical significance levels of 7.8 sigma in one refined analysis and 7.6 sigma in another. No matter how they approached the problem, no matter what computational methods they used, no matter how conservative their assumptions became, the conclusion remained the same. The transients were systematically and significantly avoiding Earth's shadow. Based on the magnitude of this deficit, the team was able to estimate that roughly 1/3 of the entire transient population in their sample consisted of genuine reflections of sunlight from physical objects in orbit. This implied the existence of a substantial population of reflective objects in Earth's vicinity during the pre-Sputnik era. The power of this statistical test was such that even highly conservative interpretations of the data couldn't eliminate its significance. If one were to assume that 90% of the total sample consisted of random plate defects, digitization artifacts, and other spurious detections, the remaining 10% of genuine events would still exhibit this highly significant avoidance of Earth's shadow. The Umbra test had accomplished something remarkable in the annals of science. It had provided overwhelming statistical evidence that a substantial fraction of the Palomar transients were not artifacts of any kind. They were real, physical phenomena occurring in Earth's orbital environment, visible only when illuminated by direct sunlight, and invisible when that sunlight was blocked by our planet's bulk. This pivotal result fundamentally shifted the direction of the entire investigation. The primary question was no longer, are these real? But rather the far more profound and unsettling query, what are they? The darkness of Earth's shadow had become a spotlight, illuminating the presence of objects that, according to our understanding of space exploration history, shouldn't have existed. The test had solved one mystery only to create a much larger one. If reflective objects were orbiting Earth in the 1950s, catching and reflecting sunlight from altitudes comparable to modern geosynchronous satellites, then the entire timeline of humanity's entry into space needed to be reconsidered. The night sky of the pre-Sputnik era, researchers now knew with statistical certainty, had not been empty at all. Part 3. Ghosts in the Machine, Debunking the Mundane. The scientific method demands that extraordinary claims face extraordinary scrutiny. Before any unconventional hypothesis can be seriously entertained, every conceivable prosaic explanation must be systematically examined, tested, and either validated or discarded. The Umbra test had provided compelling evidence that something real was creating the transients, but skeptics weren't ready to concede defeat. If anything, the stakes had risen dramatically. Now they needed to explain how genuine physical phenomena could appear in the supposedly pristine pre-Sputnik sky. The most persistent and technically sophisticated counterargument came from researchers Hambley and Blair in 2024, who published a detailed analysis arguing that the transients reported by Villarroel and her colleagues were likely emulsion artifacts rather than genuine astronomical phenomena. Their critique wasn't based on casual dismissal, but on careful image analysis that revealed a potentially damning piece of evidence. Hambley and Blair's smoking gun was their discovery that the transient images were, on average, sharper and more circular than the images of genuine stars appearing on the same photographic plates. To many observers, this seemed like conclusive proof that the transients were indeed artifacts. After all, if these were real astronomical objects, subject to the same atmospheric and instrumental effects as the surrounding stars, shouldn't they appear equally blurred and distorted? The logic seemed airtight. Genuine astronomical point sources observed through Earth's atmosphere and recorded on long-exposure photographs should be subject to the same optical effects that blur stellar images. The fact that the transients appeared sharper than nearby stars suggested they were created by a different process entirely, most likely flaws in the photographic emulsion itself. However, this apparently devastating critique was built on a fundamental misunderstanding of the physics of long-exposure astrophotography. Villarroel, Solano, and Marcy responded in 2025 with a detailed rebuttal that not only demolished the critics' argument, but turned their evidence completely on its head, transforming what was meant to be a debunking into powerful supporting evidence for the reality of the transients. The rebuttal delved into the fundamental physical processes that affect astronomical images during long exposures. When Palomar Observatory conducted its 40 to 50-minute exposures, the stellar images were inevitably degraded by three major factors that accumulated over the full duration of each observation. First was atmospheric seeing, the continuous turbulence in Earth's atmosphere that causes stars to twinkle and their light to wander randomly across the photographic plate. Over a 50-minute exposure, this atmospheric turbulence smears each star's light across a much larger area than would occur in an instantaneous photograph. Second were mechanical vibrations caused by wind buffeting the telescope, tiny imperfections in the drive motors, and thermal expansion and contraction of the instrument structure. These effects, minimal over short periods, accumulate significantly over nearly an hour of exposure time, further blurring and distorting the stellar images. Third were tracking errors in the telescope's drive system. No mechanical system is perfect, and tiny errors in following the apparent motion of stars across the sky compound over long exposures, causing additional elongation and blurring of stellar images. The crucial insight that demolished the critics' argument was recognition that a genuine transient flash lasting less than a second would be far too brief to be affected by any of these cumulative degradation effects. Such a flash would essentially capture a single, instantaneous snapshot of the atmospheric and instrumental conditions, freezing the image before the various blurring effects could accumulate. Therefore, the established principles of optical physics actually predict that a real, sub-second flash of light should produce an image that is inherently sharper and more circular than the surrounding stars, which have been blurred by nearly an hour of atmospheric turbulence, mechanical vibrations, and tracking errors. In a stunning reversal, the very evidence that Hambley and Blair had presented as proof that the transients were artifacts became strong corroborating evidence that they were indeed brief flashes of reflected light, exactly as the Vasco team had proposed. This wasn't merely a defensive response, it was an offensive demonstration that the physics of long-exposure photography actually supported the transient hypothesis. The sharpness of the transient images wasn't a bug in the data, it was a feature that confirmed their nature as brief optical events. Other conventional explanations faced similar systematic demolition under careful analysis. The hypothesis that the transients might be caused by high-altitude balloons, a popular explanation in UFO debunking circles during the 1950s, was ruled out by basic kinematics. Any balloon, regardless of altitude, would be moving relative to the fixed stars during a long exposure. Since the telescope was tracking the sidereal motion of the stellar background, a balloon would create a distinct streak or trail across the photographic plate, not a stationary point source. Furthermore, the materials commonly used for high-altitude balloons during the 1950s, typically polypropylene or similar plastic films, were not sufficiently reflective to create the bright glints observed on the Palomar plates. The intense, point-like flashes required mirror-quality reflective surfaces, not the diffuse scattering produced by balloon materials. The possibility that the transients were caused by asteroids or meteorites faced identical fundamental problems related to motion. Like balloons, these natural objects would be moving relative to the background stars and would therefore produce streaks rather than point sources during long exposures. Even a very distant, slow-moving asteroid that might appear nearly stationary during a single exposure would still be detectable in subsequent images taken minutes or hours later as it continued along its orbital path. The Vasco team's rigorous definition of transients specifically required that candidate objects appear in only one image and be completely absent from all adjacent plates of the same sky region. This criterion was verified using a blink comparator method, analogous to the technique that Clyde Tombaugh famously used to discover Pluto by comparing photographic plates taken on different nights. Even more fundamentally, the orbital mechanics of the solar system work strongly against natural explanations for the observed phenomena. For a natural object, like an asteroid or captured meteorite, to settle into a stable, high-altitude orbit similar to modern geosynchronous satellites is extraordinarily improbable from a physics standpoint. Gravitational captures of natural objects by Earth typically result in highly elliptical, chaotic orbits that decay rapidly due to atmospheric drag and other perturbations. The stable, circular, high-altitude orbits implied by the transient's stationary appearance relative to the stellar background are characteristic of deliberately placed artificial objects, not naturally captured debris. The systematic elimination of mundane explanations hadn't occurred through casual dismissal or wishful thinking, but through rigorous application of known physics and careful analysis of observational evidence. Each proposed conventional explanation was found wanting when confronted with the specific characteristics exhibited by the transient population. While it remained theoretically possible that any individual transient might represent a cleverly disguised artifact or an extremely unusual natural phenomenon, the population as a whole, particularly the subset that demonstrably avoided Earth's shadow and the cases that appeared in statistically significant geometric patterns, could not be explained by plate floors, balloons, asteroids, atmospheric phenomena, or any other conventional cause that had been proposed. The process of elimination had worked exactly as the scientific method demands. By systematically ruling out the ordinary, it had forced the investigation into extraordinary territory. The ghosts in the machine weren't ghosts at all. They were something far more intriguing, something that demanded explanations beyond the comfortable boundaries of established astronomical science. What remained were objects that reflected sunlight, occupied satellite-like orbits, appeared in structured patterns, and had been present in Earth's vicinity years before humanity's official entry into space. The mundane explanations had been exhausted through careful analysis rather than casual dismissal. Now came the far more difficult and unsettling question: if these weren't artifacts, and if they weren't natural phenomena, then what exactly were they? Part 4. The Geometry of a Glint, Profiling the Unknowns. With conventional explanations systematically eliminated and the reality of a reflective object population established through the Umbra test, the investigation shifted from determining whether these phenomena existed to understanding what they actually were. The brief flashes of light captured decades ago on glass plates, frozen in time by long photographic exposures, contained subtle but crucial clues about the physical nature of whatever had created them. The first and most fundamental characteristic that emerged from the data analysis was the object's extraordinary reflectivity. To produce bright, point-like flashes visible from the enormous distances implied by geosynchronous orbits, Dr. Villarroel explained, the surfaces creating these reflections must be super flat and super reflective. This wasn't the gentle, diffuse glow that you might expect from a spherical natural object like an asteroid or an ice crystal floating in space. The physics of light scattering made the distinction clear and crucial. A rough, spherical, or naturally textured surface would scatter incoming sunlight in many directions, producing a much fainter and more continuous reflection that would likely appear as a faint streak or glow spread across a long photographic exposure. To generate the observed phenomenon, an intense, brief flash that could saturate a point on the photographic emulsion from distances of tens of thousands of kilometers, required surfaces that acted like precision mirrors. This led to the development of a simple but powerful mental model that became central to understanding the transient phenomena, the tumbling mirror. Picture a small, perfectly flat mirror spinning end over end through the vacuum of space. For the vast majority of its rotation cycle, this mirror would reflect sunlight harmlessly away from Earth, remaining completely invisible to any ground-based observer. The cosmic void would swallow the reflected light, and the object would remain as dark and undetectable as any non-reflective piece of space debris. However, for a fleeting moment, perhaps lasting only a fraction of a second, the mirror's orientation would align perfectly with the geometry of the Sun, the reflective surface, and an observer on Earth's surface. During this brief instant, the mirror would act like a cosmic signal mirror, focusing reflected sunlight into an intense, concentrated beam directed precisely toward our planet. The result would be a brilliant glint of reflected light, lasting just long enough to register as a point source on a long photographic exposure, before the continued rotation carried the reflective surface away from the critical alignment angle. This specular reflection model explained not only the brightness and brief duration of the transients, but also their sharp, point-like appearance on the photographic plates. Unlike the continuous tracking of a moving object that would create a streak, or the extended exposure of a stationary light source that might create a larger, more diffuse image, these brief glints would appear as perfect points, intense enough to register clearly but brief enough to avoid the cumulative blurring effects that affected stellar images during long exposures. To test the plausibility of this tumbling mirror hypothesis, the team's colleague Hisham conducted detailed computer simulations designed to determine what kinds of three-dimensional shapes and geometries could produce the observed glint patterns. These simulations were particularly important for understanding cases where multiple, aligned transients appeared on single photographic plates, suggesting either multiple objects in formation or single objects with multiple reflective surfaces. The computer modeling wasn't intended to provide definitive blueprints of actual objects, but rather to serve as plausibility arguments, demonstrations that the observed phenomena could indeed result from reasonable geometric configurations of reflective surfaces in space. The simulations explored several categories of non-spherical shapes, each featuring limited, flat, highly reflective surfaces attached to primarily non-reflective main bodies. Among the geometries tested were cone-shaped objects with reflective surfaces on their top and bottom faces, double pyramid structures with multiple flat facets, complex polyhedrons with several mirror-like panels, and simpler configurations resembling modern satellites with two reflective panels similar to solar arrays. Each of these basic shapes was subjected to realistic rotational dynamics, including both simple rotation around a central axis and more complex precession, a wobbling motion in the orientation of the rotation axis that commonly affects objects in space. The simulation results were remarkably encouraging for the specular reflection hypothesis. All the tested geometries, when subjected to realistic rotation and precession over the course of a 50-minute photographic exposure, could easily produce multiple distinct, aligned glints spaced along the object's apparent path across the sky. The spacing, brightness, and timing of these simulated glints matched well with the patterns observed in the most compelling transient alignments found in the Palomar data. Crucially, the simulations demonstrated that the reflective surfaces need not constitute the entire object or even its primary structure. A small mirror-like component, perhaps a metallic panel, an antenna, or a specialized reflector attached to a much larger, darker, and more complex main body could produce identical optical effects. This insight explained why only the brief flashes were visible in the historical photographs, while the objects themselves remained too dark, too small, or too non-reflective to register as detectable sources on the sensitive but limited photographic plates of the era. The question of size proved more challenging but not impossible to address through the available data. While precise measurements of object dimensions from simple glints were not feasible, the team was able to make reasonable order of magnitude estimates by comparing the apparent brightness of the transients to the known brightness of modern space debris and active satellites in similar orbital locations. This comparative brightness analysis suggested that the objects responsible for the transients were likely between 10 centimeters and a few meters in their largest dimensions. This size range was particularly significant because it ruled out both extremely small objects, which wouldn't produce sufficiently bright reflections to register on the plates, and enormous structures that would likely have been detected through other means or would have produced more complex reflection patterns. The inferred size range was entirely consistent with small satellites, specialized probes, or technological components of the type that humanity would eventually deploy in Earth orbit. Importantly, the objects didn't need to be colossal alien motherships or massive space stations to account for the observed phenomena. Their estimated dimensions aligned well with practical, purpose-built technological artifacts designed for specific functions in the space environment. When directly pressed about the implications of their findings during recorded interviews, Dr. Villarroel's response was remarkably candid and scientifically honest. When asked whether the observed glints could be consistent with highly reflective, disc-shaped objects, the classic flying saucer configuration that has dominated popular culture for decades, she replied without hesitation, "Of course, I think that's the best explanation so far." This statement wasn't based on speculation, wishful thinking, or adherence to popular mythology, but on the cold logic of optical physics and engineering practicality. A flat, disc-shaped object with a highly reflective upper or lower surface would be geometrically ideal for producing the kind of brief, intense, specular reflections observed in the Palomar data. Such a configuration would maximize reflective area while minimizing the duration of reflection events as the object rotated, creating exactly the type of brief, bright glints that had been detected. The geometry of the glints themselves told a compelling story that natural phenomena struggled to explain convincingly. The combination of high orbital altitude, extreme surface reflectivity, flat angular geometry, and brief flash duration created a highly specific physical profile. This wasn't the signature of a tumbling rock or an ice crystal drifting randomly through space. It was the profile of something engineered, something designed, something that exhibited the hallmarks of deliberate construction and purposeful deployment. This technical profiling inevitably led to a conclusion that made many researchers uncomfortable. The transient phenomena exhibited characteristics that aligned much more readily with artificial objects than with any known natural phenomena. The geometry of the glints argued for a technological origin, for surfaces designed and manufactured rather than naturally formed, for objects placed in specific orbits rather than randomly captured by Earth's gravity. The investigation had progressed beyond proving that something unusual existed to developing a detailed physical profile of what that something might be. And that profile, however unsettling it might be for conventional space history, looked increasingly like technology that had been operating in Earth's orbital environment years before humanity had officially placed its first artificial satellite in space. Part 5. Patterns in the Sky. The Aligned Transients. While the Umbra test had provided overwhelming statistical validation for the existence of genuine reflective objects among the transient population, a smaller but even more extraordinary subset of these events exhibited characteristics that elevated the mystery to an entirely new level. These were the aligned transients, multiple simultaneous point sources appearing in precise geometric patterns that defied any reasonable explanation based on random occurrence or coincidental alignment. The discovery of these structured patterns required painstaking analysis of the VASCO database, which by this point contained over 100,000 transient candidates from the Northern Hemisphere alone. The team's sophisticated algorithms systematically scanned this massive dataset, searching for spatial clusters of transients that occurred within the same photographic exposure and examining whether these clusters exhibited any non-random geometric organization. The search parameters were carefully designed to identify instances where 3, 4, 5, or more point sources aligned along narrow bands within the angular resolution limits of the photographic plates. This wasn't simply a matter of finding transients that appeared in the same general region of sky. The analysis specifically looked for precise linear arrangements that would be statistically improbable if the transients were distributed randomly across the available area. To ensure objectivity and avoid the trap of seeing patterns where none existed, the researchers employed a robust statistical framework originally developed by astronomer M.G. Edmonds for analyzing random point distributions. This mathematical approach provides precise formulae for calculating the expected number of chance alignments that should occur when a given number of points are scattered randomly across a defined area, allowing researchers to assign exact probability values to each candidate pattern. The Edmonds framework enabled the team to move beyond subjective judgments about what looked like a meaningful pattern and instead calculate objective probabilities for each potential alignment. This quantitative approach was essential for distinguishing genuine geometric structure from the kind of apparent patterns that human minds are evolutionarily predisposed to detect even in purely random data. The systematic search through the Northern Hemisphere database yielded 83 initial candidate alignments of 3 or more transients within single photographic exposures. However, the team applied rigorous filtering criteria to eliminate false positives and ensure that their final candidates represented genuine phenomena rather than artifacts of the detection or analysis process. The most critical filtering step involved cross-verification using independent digital scans of the same physical photographic plates. Each alignment candidate had to be confirmed as present in both the digitized sky survey scans and the Super Cosmos sky survey scans of the identical physical plate. This cross-checking procedure was vital for eliminating apparent alignments that might have been introduced during the digitization process itself, ensuring that the patterns existed in the original photographic data rather than in the digital processing pipeline. This verification process reduced the candidate list to 5 exceptional cases that survived all screening procedures and exhibited statistical significance levels that demanded serious scientific attention. Each of these surviving candidates demonstrated alignment, precision, and statistical improbability that placed them far outside the realm of random coincidence. Candidate 3, recorded on December 21, 1954, showed a remarkable 5-point alignment contained within a 15 by 15 arc-minute square region of sky. The statistical analysis revealed that the probability of such a precise arrangement occurring by random chance within that specific image area was just 0.002, odds of approximately 1 in 500. Candidate 4, captured on August 5, 1954, featured a 4-point alignment with similarly impressive statistical credentials. The chance probability for this geometric pattern was calculated at 0.003, representing odds of roughly 1 in 333 that such an arrangement could result from random distribution of points across the plate. However, the crown jewel of the alignment analysis was Candidate 5, recorded on the night of July 27, 1952. This photographic plate captured 5 distinct transients, arranged in a narrow linear band with geometric precision that was almost impossible to believe. The statistical analysis of this configuration yielded a probability of just 0.0001, a 1 in 10,000 chance of random occurrence. In the formal language of statistical significance, this represented approximately 3.9 sigma, a level that commands serious attention in any scientific field. To appreciate just how extraordinary such an alignment would be, imagine scattering 5 grains of rice randomly across a large dining table and discovering that they had, by pure chance, formed a perfectly straight line. The mathematical framework confirmed what intuition suggested. Such patterns are vanishingly rare in truly random distributions. The physical implications of these statistically improbable alignments opened fascinating avenues for interpretation and analysis. If a series of aligned glints originated from a single rotating object moving across the sky during the 50-minute exposure, the straight line would represent that object's trajectory projected against the stellar background. The spacing between individual glints could then provide crucial information about the object's rate of rotation, while variations in brightness might reveal details about the geometry and orientation of its reflective surfaces. Alternatively, the linear arrangements might represent multiple independent objects flying in precise formation, a possibility that would be even more difficult to explain through conventional means, but that would align with organized, coordinated behavior rather than random natural phenomena. The discovery of these alignments provided a second, completely independent line of evidence that complemented and reinforced the findings from the Umbra test. While the shadow avoidance analysis had demonstrated that many transients were genuine reflections rather than plate defects, the geometric pattern analysis showed that some of these genuine reflections appeared in highly structured, non-random arrangements that spoke of underlying organization or physical constraints. The statistical framework made it clear that these weren't cases of researchers seeing patterns where none existed, a common pitfall in data analysis where the human tendency to detect meaningful arrangements can lead to false conclusions. The mathematical rigor of the Edmonds approach provided objective quantification of just how improbable these alignments were, removing subjective interpretation from the evaluation process. Moreover, the alignments represented a different type of anomaly than the simple presence or absence of transients revealed by the Umbra test. These were positional correlations within individual exposures, demonstrating that whatever was creating the transients was capable of producing spatially organized patterns that extended across significant portions of the sky during single observation periods. The implications extended beyond simple confirmation that the phenomena were real. The structured nature of the alignment suggested that the underlying causes, whether natural or artificial, operated according to physical principles that produced geometric order rather than random distribution. This was evidence of phenomena governed by laws, constraints, or intentions that went beyond the chaotic scatter expected from purely random processes. From a broader perspective, the aligned transients added another layer of improbability to the overall phenomenon. It was already statistically extraordinary that transients avoided Earth's shadow with 22 sigma significance. Now, researchers had to account for the additional improbability that some of these shadow-avoiding, presumably reflective objects also appeared in geometric patterns with odds against random occurrence ranging from 1 in 300 to 1 in 10,000. The compound improbability of multiple independent statistical anomalies occurring in the same dataset strengthened the case that the transients represented genuine physical phenomena rather than artifacts or coincidences. When multiple lines of evidence, each statistically significant on its own, pointed toward the same conclusion, the combined case became far stronger than any single analysis could provide. The discovery of structured patterns in the transient data marked a crucial turning point in the investigation. The phenomena were no longer just a collection of individual anomalies that might be explained away through various ad hoc hypotheses. They had revealed themselves as exhibiting geometric organization and statistical structure that demanded comprehensive explanation rather than piecemeal rationalization. As the research progressed from proving existence to characterizing behavior, the aligned transients provided crucial constraints on any theoretical framework that attempted to account for the observations. Any successful explanation would need to address not only why objects appeared to be orbiting Earth before Sputnik, not only why they avoided Earth's shadow like genuine reflective surfaces, but also why they sometimes appeared in precise geometric arrangements that defied random chance. The patterns in the sky had transformed the investigation from a search for anomalous objects into a study of apparently organized phenomena that exhibited both physical constraints, like shadow avoidance, and geometric structure, like linear alignments. Whatever was creating these effects was operating according to principles that produced order rather than chaos, structure rather than randomness, patterns rather than arbitrary distribution. Part 6. The Washington Merry-Go Round. The scientific evidence for the Palomar transients was already compelling when considered in isolation, but the investigation was about to intersect with history in a way that would add layers of significance that no one had anticipated. The dates when the most remarkable transient events were recorded weren't scattered randomly across the 1950s, they aligned with extraordinary precision to one of the most famous, well-documented, and thoroughly investigated UFO incidents in American history, the 1952 Washington, D.C. UFO flap. To understand the full significance of this temporal correlation, we must first revisit the historical context of those remarkable July nights that forever changed how official America addressed the question of unidentified aerial phenomena. July 1952 was a month that marked a watershed moment in the relationship between the US government, the military establishment, and the enigma of unexplained objects in American airspace. The first wave of extraordinary events began during the weekend of July 19th through 20th, 1952. What started as routine radar operations at Washington National Airport quickly escalated into a multi-site, multi-platform detection event that would dominate national headlines and force the highest levels of government to publicly address phenomena that had previously been dismissed or ignored. Radar operators at 3 separate and independent facilities, Washington National Airport, Andrews Air Force Base, and Bolling Air Force Base, began detecting solid, persistent radar contacts moving through some of the most restricted and heavily monitored airspace in the United States. These weren't fleeting blips, instrument malfunctions, or ambiguous signatures that could be easily dismissed. They were sustained, trackable contacts that appeared simultaneously on multiple radar systems and persisted long enough for operators to vector aircraft toward them and attempt intercepts. The objects demonstrated flight characteristics that defied every conventional explanation available to military and civilian aviation experts of the era. They moved at speeds far beyond any known aircraft, executed impossible maneuvers that would have destroyed conventional airframes, and exhibited what appeared to be intelligent responses to human attempts at interception. When F-94 Starfire interceptor jets were scrambled from nearby airbases to investigate the contacts, the objects would often vanish from radar screens as the fighters approached, only to reappear once the military aircraft had departed the area. The radar contacts weren't occurring over empty countryside or remote military installations where they might be dismissed as equipment malfunctions or misidentified natural phenomena. They were tracking directly over the White House, the Capitol building, and other sensitive government facilities in the heart of the nation's capital. The implications for national security were immediate and alarming. What made these events impossible to dismiss or classify was the multiple platform confirmation they received. The radar contacts were simultaneously confirmed by visual sightings from experienced commercial airline pilots, air traffic controllers, and the crews of military interceptor aircraft. These weren't single witness accounts or anecdotal reports. They were coordinated observations from multiple trained professionals using different detection methods and working at different locations. It was on this exact night of July 19th through 20th, 1952, hundreds of miles away at Palomar Observatory, that a photographic plate captured what Enrique Solano would later describe as a super beautiful, triple transient, three bright, star-like objects that appeared together in perfect coordination and then vanished completely from subsequent observations of the same sky region. The correlation between radar-tracked objects over Washington and simultaneously appearing optical transients in California was remarkable enough to merit attention, but the pattern was far from complete. The Washington events would return with even greater intensity exactly 1 week later, and once again, the Palomar plates would record corresponding anomalies. The second wave of the Washington flap occurred during the weekend of July 26 through 27, 1952, and it surpassed the previous weekend's events in both intensity and official response. Multiple radar installations across the Washington area lit up with anomalous contacts that appeared to be systematically surveying the most sensitive military and government installations in the United States. The objects tracked by radar demonstrated the same impossible flight characteristics observed the previous weekend, but this time the activity was more sustained, more widespread, and more difficult for official channels to ignore or explain away. Commercial airline flights reported visual contact with objects that corresponded to radar tracks. Military personnel at multiple installations confirmed the presence of phenomena that seemed to be conducting organized reconnaissance of restricted facilities. The events generated such widespread public attention and official concern that they triggered what became the largest press conference in Air Force history up to that point. Major General John Samford, the Air Force Director of Intelligence, was compelled to address the nation's media and attempt to provide a rational explanation for events that had been witnessed by dozens of trained professionals and tracked by multiple independent radar systems. General Samford's explanation that the radar contacts and visual sightings were caused by temperature inversions and other atmospheric phenomena became the government's official position on the Washington events. However, this explanation satisfied few of the actual witnesses who had observed the phenomena firsthand, and it marked the beginning of decades of official policy that would systematically dismiss or debunk reports of aerial anomalies regardless of their credibility or the qualifications of those reporting them. This second weekend of the Washington flap corresponds with remarkable precision to July 27, 1952, the exact date when the most statistically significant finding in the Vasco alignment search was recorded. The photographic plate containing Candidate 5, with its 5-point linear arrangement carrying 1 in 10,000 odds against random occurrence, was exposed during the same night that radar screens across the nation's capital were tracking unidentified objects over the most restricted airspace in America. The probability that such a temporal correlation could occur by pure chance was extraordinarily small. Dr. Villarreal noted that finding one such correlation between Palomar transients and major UFO events might be dismissed as a remarkable coincidence. But discovering two separate, highly unusual transient events that aligned perfectly with the two specific weekends of the most significant and well-documented UFO incident of the era suggested something far more profound than random chance. The correlation implied that whatever phenomena were being detected through optical astronomy in California weren't localized, isolated events. It suggested that during those specific weekends in July 1952, something unusual was occurring on a continental scale, detectable through multiple independent technologies and observation methods, radar systems in Washington, D.C., visual observations by trained pilots and air traffic controllers, and long-exposure astronomical photography hundreds of miles away in Southern California. For the Vasco research team, this historical intersection raised intriguing methodological possibilities. If the correlation between transients and documented UFO events was genuine rather than coincidental, then archives of high-quality UAP reports might serve as a predictive tool for future research. Historical databases of credible sightings could guide researchers towards specific dates in photographic plate collections that would be most likely to yield additional discoveries. The Washington connection transformed the Palomar findings from an isolated astronomical curiosity into part of a broader pattern of phenomena that had, during a brief period in the early 1950s, made themselves simultaneously visible to different detection systems across the United States. The transients weren't just anomalous objects recorded by a single observatory, they were part of a larger picture of activity that had been observed, tracked, and documented through multiple independent means during the same time periods. This realization forced a fundamental shift in how the transient phenomena should be understood and investigated. Rather than being quirky astronomical anomalies that might be explained through exotic astrophysics or instrumental artifacts, they appeared to be part of organized activity that had occurred during specific, historically significant time periods when similar phenomena were being reported through entirely different observation networks. The tale of 2 weekends in July 1952 had become a tale of coordinated phenomena observed through different methodologies, different locations, and different recording systems, all pointing toward the same unsettling conclusion. Something extraordinary had been happening in American skies during those pivotal weekends. Something significant enough to trigger the largest Air Force press conference in history and leave permanent traces in the archives of one of the world's most prestigious astronomical observatories. Part 7. Echoes of the Atomic Age. The striking temporal correlation between Palomar transients and the Washington UFO flap represented just the beginning of a much deeper and more systematic investigation into the relationship between these anomalous phenomena and the 4T flap. Pivotal events of the early atomic age. The discovery that the most significant transient events aligned precisely with major UFO incidents raised an inevitable and profound question. If these phenomena were linked to one major historical event, what other connections might exist with the defining activities of the Cold War era? This question led Dr. Villarreal and her colleague Stephen Brule to undertake one of the most comprehensive statistical analyses ever applied to the intersection of unexplained aerial phenomena and nuclear weapons testing. Their investigation would span the crucial period from November 19, 1949 to April 28, 1957, covering 2,718 days during the height of atmospheric nuclear testing by the world's emerging superpowers. The scope and ambition of their analysis was unprecedented in UFO research. Rather than relying on anecdotal accounts or casual observations, they constructed a rigorous daily database that merged 3 completely independent data streams into a single, comprehensive dataset that could be subjected to sophisticated statistical analysis. The first data stream consisted of the Palomar transient counts, meticulously extracted from the Vasco database and organized by observation date. This provided a day-by-day record of how many anomalous point sources had been detected in the skies above Southern California during each night of astronomical observation. The second stream drew from UFOCAT, one of the most comprehensive historical databases of UFO reports, containing thousands of independent sighting reports from across the United States and around the world. These reports were organized by date and geographic location, providing a quantitative measure of UFO activity that could be correlated with other variables. The third stream documented every known above-ground nuclear weapons test conducted by the United States, the Soviet Union, and Great Britain during this period. This included not only the dates of the detonations themselves, but also information about their locations, yields, and atmospheric effects. The resulting master database represented an extraordinary resource for investigating potential correlations between these phenomena using the rigorous statistical methods employed in epidemiology, economics, and other fields that study complex relationships between multiple variables. The first hypothesis they tested had long been part of UFO folklore, but had never been subjected to systematic quantitative analysis. Was there a statistical correlation between nuclear weapons testing and the occurrence of anomalous aerial phenomena? The team considered two potential mechanisms that might explain such a correlation. The first possibility was that nuclear detonations created previously unrecognized atmospheric or ionospheric effects that could manifest as glowing phenomena visible to ground-based observers. The early atomic tests had produced many unexpected effects, from the discovery of electromagnetic pulse damage to the creation of artificial auroras. Perhaps they were also generating high-altitude optical phenomena that resembled the blue orbs associated with Cherenkov radiation that were occasionally reported in nuclear test zones. The second, more speculative possibility was that non-human observers were being drawn to displays of nuclear technology, and that their presence in increased numbers during test periods led to more frequent detections of their reflective surfaces by astronomical instruments and more numerous sightings by ground-based witnesses. The statistical analysis of the nuclear test correlation produced unambiguous results that validated decades of anecdotal claims with hard quantitative evidence. Transient events at Palomar Observatory were 45% more likely to occur within a plus or minus 1 day window around nuclear weapons tests, a correlation with a p-value of 0.008, highly unlikely to result from random chance alone. This wasn't just a matter of statistical significance, it was also practically significant. The analysis showed that not only were transients more frequent on days close to nuclear tests, but that the total numbers of transients recorded on these days were substantially elevated compared to baseline levels. The second major correlation tested the relationship between Palomar transients and UFO reports from across the United States. This analysis examined whether days with higher numbers of independent UFO sightings were also days when more transients were detected at the California Observatory. Once again, the statistical results were highly significant, with a p-value of less than 0.001. The analysis revealed that for every additional UFO report recorded on any given day, there was an 8.5% increase in the expected number of transients observed at Palomar Observatory. This represented the first quantitative validation of a suspected relationship between local astronomical anomalies and broader patterns of aerial phenomena reported across the country. The third leg of the analysis examined whether the long-standing anecdotal connection between nuclear testing and UFO sightings could be validated through systematic statistical analysis. This correlation had been claimed by UFO researchers for decades, but had never been rigorously tested using comprehensive databases and proper statistical methods. The data confirmed this relationship as well, showing that UFO reports were significantly elevated within the nuclear testing time windows, with a p-value of 0.008. This provided the first peer-reviewed statistical support for one of the most persistent claims in UFO literature, that nuclear weapons testing was correlated with increased reports of anomalous aerial phenomena. The overall conclusion of the Bruhl and Villarol study was profound and unprecedented. Rather than finding just one significant correlation, their analysis had uncovered what they termed a trinity of correlations, a three-way statistical relationship linking Palomar transients, UFO reports, and nuclear weapons tests in ways that chance alone could not explain. The significance of these interconnected correlations extended far beyond their individual statistical strength. The study demonstrated that these three apparently separate phenomena, astronomical transients detected at a single observatory, UFO reports from across the country, and nuclear weapons testing by multiple nations, were all statistically linked in ways that suggested underlying causal relationships rather than mere coincidence. Perhaps even more remarkably, the effects appeared to be additive rather than independent. The days with the highest numbers of recorded transients were those that fell within nuclear testing windows and also had at least one UFO report in the national database. This suggested that the phenomena might be reinforcing each other through some unknown mechanism, with nuclear testing, UFO activity, and transient detections all contributing to elevated levels of anomalous activity. The statistical web of correlations created a picture that was extraordinarily difficult to reconcile with conventional explanations. Random photographic plate defects don't coordinate their occurrence with human nuclear weapons testing schedules. Emulsion flaws don't peak during periods when UFO reports are elevated across the country. Digitization artifacts don't follow the geopolitical rhythms of Cold War atmospheric testing programs. Instead, the data pointed toward genuine physical phenomena that were, for reasons that remained mysterious, intimately connected with humanity's development and testing of nuclear weapons during the early atomic age. The correlations suggested that something had been responding to, monitoring, or perhaps even being triggered by the atmospheric detonation of nuclear devices during this crucial period in human technological development. Perhaps the most puzzling finding in the entire analysis was the discovery of a distinct temporal cutoff in these correlations. The strong statistical relationships between transients and nuclear testing appeared to cease abruptly after March 17, 1956. This cessation occurred despite the fact that 38 additional above-ground nuclear tests were conducted over the subsequent 13 months covered by the study period. This mysterious halt in the correlations aligned with independent research that had noted a similar, sudden decrease in UFO reports at nuclear weapons facilities between 1953 and 1956. The parallel timing suggested that whatever was creating these statistical relationships had either ceased its activity or fundamentally changed its behavior patterns around the middle of the 1950s. The implications of this temporal cutoff were deeply puzzling. If these were natural phenomena triggered by nuclear detonations, why would they suddenly stop responding to continued atmospheric testing? If they were observations by non-human intelligence, what had changed in 1956 to alter their apparent interest in human nuclear activities? The echoes of the atomic age, preserved in the statistical relationships between nuclear testing, UFO reports, and astronomical transients, painted a picture of phenomena that were far more complex and organized than random natural events or instrumental artifacts could explain. They suggested that during the crucial early years of the nuclear era, something had been watching, responding to, and perhaps evaluating humanity's first steps toward technologies capable of planetary destruction. Part 8. The Menzel Gap, a Conspiracy of Silence. The remarkable correlations uncovered by the statistical analysis raised a troubling question that struck at the heart of scientific integrity and historical completeness. If objects exhibiting satellite-like behavior were present in Earth's orbital environment during the 1950s, and if their activity correlated significantly with nuclear weapons testing and UFO reports, why hadn't similar evidence been discovered in the extensive archives of other major observatories around the world? The answer to this question may lie in one of the most disturbing episodes in the history of astronomical data preservation, an act of scientific vandalism that occurred just months after the most famous UFO incident of the 20th century, and that was perpetrated by the very scientist who had been tasked with providing the official government explanation for those events. At the center of this troubling story stands Dr. Donald Menzel, one of the most prominent and respected astronomers of his generation. Menzel held the position of professor of astrophysics at Harvard University and was widely regarded as a leading authority on stellar physics and solar astronomy. His scientific credentials were impeccable, his research contributions significant, and his standing in the astronomical community unquestioned. However, Menzel also played a crucial and controversial role in the government's response to the 1952 Washington, D.C. UFO incidents. The U.S. Air Force specifically recruited Menzel to help formulate their public explanation for the radar contacts and visual sightings that had captivated the nation and generated unprecedented media attention. It was Menzel's scientific analysis of temperature inversions and atmospheric anomalies that provided the theoretical foundation for Major General John Samford's historic press conference, which attempted to dismiss the Washington sightings as misidentified natural phenomena. The official explanation crafted by Menzel and promoted by the Air Force became the template for decades of systematic debunking efforts. His arguments about atmospheric distortions, radar anomalies, and optical illusions would be recycled and refined by subsequent generations of skeptics and debunkers, establishing him as one of the founding figures of scientific UFO denial. 2 months after General Samford's press conference, Menzel was appointed to one of the most prestigious positions in American astronomy, director of Harvard College Observatory. At the time of his appointment, Harvard housed one of the world's largest and most historically significant collections of astronomical photographic plates. This archive represented over a century of systematic sky observations, containing hundreds of thousands of plates that documented changes in stellar brightness, the discovery of variable stars, and the long-term behavior of celestial objects across the entire observable sky. These plates were more than just historical curiosities. They were irreplaceable scientific data that provided the only long-term record of astronomical phenomena spanning multiple decades. The Harvard Plate Collection was considered a priceless scientific resource used by researchers around the world to study stellar evolution, discover new classes of variable objects, and trace the historical development of astronomical knowledge. What happened next represents one of the most shocking acts of data destruction in the annals of modern science. One of Menzel's first official acts as the new director was to issue an order that stunned his colleagues and violated every principle of scientific data preservation. He instructed his secretary to dispose of, remove, or otherwise destroy 1/3 of Harvard Observatory's entire photographic plate collection. Along with the plates themselves, many of the accompanying logbooks containing crucial observational details, timing information, and procedural notes were also marked for destruction. The magnitude of this act cannot be overstated within the culture and ethics of astronomical research. As podcast host John Michael Godier observed with incredulous amazement, "I must know 100 astronomers at this point, and I have never known an astronomer that would destroy data, not one, except for Menzel." This sentiment captures the absolute horror that such an action would inspire in any working scientist. Astronomical photographic plates are treated with the reverence that archaeologists reserve for ancient artifacts or historians accord to original documents. They represent unique, irreplaceable records of the cosmos at specific moments in time, capturing information that can never be recovered once lost. Their preservation is considered a fundamental responsibility of any observatory, and their deliberate destruction is simply unthinkable under normal circumstances. The order did not go unopposed within the Harvard astronomy community. Dr. Dorrit Hoffleit, a respected variable star researcher and one of the few senior women astronomers of her era, was horrified by Menzel's directive. Understanding the immense and irreversible scientific loss that was about to occur, she took extraordinary personal risks to prevent the destruction of as much data as possible. Hoffleit secretly began hiding stacks of plates in her office, storage areas, and anywhere else she could find space, working frantically to preserve whatever portions of the collection she could manage to save from Menzel's purge. Her covert preservation efforts represented one of the most heroic acts of scientific civil disobedience in modern history, as she risked her career and professional standing to protect irreplaceable data from deliberate destruction. Her courageous intervention came at a devastating personal and professional cost. Hoffleit fell out of grace with Menzel almost immediately after her preservation efforts became known. The observatory director began a systematic campaign of professional harassment that made her working life unbearable and ultimately forced her to leave Harvard entirely. The persecution was both petty and vindictive. Menzel deliberately undermined her research projects, blocked her access to resources, and created a hostile work environment designed to drive her from the institution. In her published memoirs, she dedicated an entire chapter to this period, titled with bitter accuracy, Persona non grata. In one particularly spiteful act of workplace harassment, Menzel had her office relocated to a space directly adjacent to the men's restroom, a degrading humiliation designed to emphasize her diminished status and unwelcome presence. Despite the professional retaliation she faced, Hoffleit's covert preservation efforts succeeded in saving a significant portion of the Harvard Plate archive from destruction. However, the plates she couldn't reach, hide, or secretly relocate were lost forever, creating what researchers now refer to as the Menzel gap, a permanent and irreversible loss of astronomical data that spans crucial years in the pre-satellite era. The official explanation for this unprecedented act of scientific vandalism was cost-cutting, the claim that Harvard Observatory could no longer afford to store and maintain such an extensive plate collection. However, this rationale fails to withstand even casual scrutiny when examined against standard practices of the time. The conventional and economically sensible method for disposing of old photographic plates was to reclaim the valuable silver content from their emulsion through chemical processing. This silver recovery not only offset the costs of storage and handling, but actually generated revenue that could fund other observatory activities. The fact that Menzel specifically ordered the plates to be thrown away rather than processed for silver recovery suggests that economic considerations were not his primary motivation. The timing and circumstances surrounding the plate destruction raise far more troubling possibilities about Menzel's true motivations. The mass destruction of astronomical data occurred just months after Menzel had played a central role in the government's official response to the most significant UFO incident in American history. He was simultaneously serving as both a respected academic scientist and a key architect of official UFO debunking policy. This dual role creates an obvious conflict of interest that raises serious questions about whether Menzel was acting purely in his capacity as Harvard Observatory director, or whether he was implementing some form of national security directive designed to remove potential evidence of the very phenomena he was being paid to publicly discredit. The speculation extends to even more disturbing possibilities. Rather than simple disposal, could the plates have been quietly extracted to government storage facilities for classified analysis? As the podcast discussion speculates, what if he shipped them away to some secret vault? While there is no direct evidence for such covert removal, the circumstances certainly warrant investigation of the plate's ultimate disposition. The Menzel episode was not isolated, but part of a broader pattern of behavior that demonstrated deep hostility toward any serious scientific investigation of aerial anomalies. Menzel was known for his professional animosity toward other respected astronomers who took UFO reports seriously, including Clyde Tombaugh, the discoverer of Pluto, who had his own credible UFO sighting and advocated for scientific investigation of the phenomenon. There are persistent, though unconfirmed, rumors that Menzel orchestrated a second episode of plate destruction during the 1960s, suggesting that the Harvard Purge may not have been an isolated incident, but part of a systematic campaign to eliminate potential evidence from multiple archives. The story of the Menzel gap serves as a stark illustration of the intense academic and institutional pressures that surrounded UFO research during the Cold War era. The scientific community was not operating in an environment of open, curious inquiry, but in a climate of fear, ridicule, and professional retaliation for anyone who expressed serious interest in aerial anomalies. Figures like Menzel, and later the arch-skeptic Philip Klass, who was notorious for his vicious personal attacks on scientists like Dr. James MacDonald, fostered an atmosphere where careers could be destroyed for asking the wrong questions or pursuing politically inconvenient research directions. This systematic suppression of scientific inquiry effectively prevented serious investigation of aerial phenomena for decades and may have resulted in the permanent loss of crucial historical evidence. The Menzel gap represents more than just missing data. It symbolizes the possibility that the historical record has been deliberately altered through the destruction of evidence that might have supported or refuted extraordinary claims about pre-satellite orbital objects. We will never know what correlations might have been discovered, what patterns might have emerged, or what additional confirmation might have been found if those destroyed plates had been preserved and subjected to the same rigorous analysis applied to the Palomar archive. The missing Harvard plates serve as a permanent reminder that the absence of evidence cannot be taken as evidence of absence, particularly when that absence may have been artificially created through deliberate destruction of historical records. The scientific investigation of aerial anomalies has been forced to proceed with incomplete data, missing archives, and the constant awareness that crucial evidence may have been systematically eliminated from the historical record. Part 9. The Alien Probe Hypothesis. Are we being watched? Having methodically eliminated mundane explanations and established the physical reality of reflective objects in pre-Sputnik Earth orbit, the investigation arrives at a crucial juncture where scientific rigor demands consideration of hypotheses that extend far beyond conventional astronomical phenomena. The evidence points toward two remaining possibilities, both extraordinary in their implications. Either these transients represent manifestations of a completely unknown natural phenomenon, or they are artifacts of non-human technological intelligence. Dr. Villarroel presents a counterintuitive argument for why the artificial hypothesis might actually represent the more scientifically parsimonious explanation. It seems simpler for me to imagine that it's something artificial, she observes with characteristic directness, just because it looks like what we see today in the sky. The objects exhibit precisely the behavioral characteristics of modern satellites: stable high-altitude orbits, specular reflections from flat surfaces, and geometric patterns that speak of engineered rather than natural origins. From this perspective, inventing an entirely new category of natural phenomenon that perfectly mimics the behavior of artificial satellites may actually be the more complex and less satisfying explanation. The artificial hypothesis requires only the existence of technology more advanced than our own, operating according to physical principles and engineering logic that we can understand and recognize. The scientific foundation for seriously considering extraterrestrial probe scenarios rests on several logical pillars that have become increasingly solid as our understanding of astrobiology, planetary science, and the potential for life in the universe has expanded. The first and most fundamental consideration is that Earth has been broadcasting its status as a life-bearing world for over 2 billion years through the chemical signature of its atmosphere. The Great Oxygenation Event, which occurred between 2.4 and 2.1 billion years ago, permanently transformed Earth's atmospheric composition by introducing large quantities of free oxygen through the metabolic processes of cyanobacteria. This created a dramatic chemical disequilibrium that serves as one of the most powerful biosignatures detectable by astronomical observation from interstellar distances. Any technologically advanced civilization within our galactic neighborhood that possessed the ability to conduct spectroscopic analysis of exoplanetary atmospheres would likely be aware that Earth hosts active biological processes. The oxygen-rich atmosphere, combined with the presence of water vapor and other biologically produced gases like methane and ozone, creates a chemical fingerprint that would be immediately recognizable to any species that had developed sophisticated astronomical observation capabilities. This means that Earth's status as a living world has been visible and detectable for geological time periods that dwarf the entire span of human civilization. If advanced civilizations exist elsewhere in our galaxy, they would have had billions of years to detect our planet's biosignature and potentially decide that it warranted closer investigation. The second pillar supporting the probe hypothesis is the recognition that interstellar travel, while representing an enormous engineering challenge, is not prohibited by the known laws of physics. The primary obstacles are technological and logistical rather than fundamental physical barriers. Advanced propulsion systems, whether based on fusion ramjets, antimatter engines, solar sails, or exotic physics we have yet to discover, could potentially enable travel between neighboring star systems within timeframes that would be acceptable to a long-lived civilization. More importantly, the key resource required for interstellar exploration is time, a commodity that civilizations millions of years older than humanity would possess in abundance. From our current perspective, interstellar distances seem impossibly vast because we measure them against human lifespans and the brief span of our technological development. But for a civilization that has been technologically active for millions of years, the galaxy becomes a much smaller and more accessible place. The third logical foundation is the recognition that any civilization advanced enough to achieve interstellar travel would almost certainly engage in systematic exploration and scientific investigation of interesting stellar systems. This is simply an extension of the exploratory behavior that has characterized human civilization throughout its development, from the earliest ocean voyages to our current robotic exploration of the solar system. Just as humanity has sent automated probes like Voyager, Pioneer, New Horizons, and countless others to explore distant worlds within our own solar system, advanced extraterrestrial civilizations would logically employ similar strategies for interstellar exploration. The deployment of autonomous robotic probes represents the most practical and efficient method for gathering information about distant worlds without the enormous costs and risks associated with crewed interstellar missions. Dr. Villarroel speculates that the most likely form of such interstellar explorers would be advanced artificial intelligence systems rather than biological entities. The development of sophisticated AI appears to be a natural technological milestone that most advanced civilizations would achieve relatively early in their development. Once created, AI probes could operate for millions of years without the biological support requirements that would make interstellar travel so challenging for living organisms. A truly advanced civilization could potentially deploy millions of such AI probes throughout the galaxy, creating a vast network of autonomous observers gathering data on planetary evolution, the emergence of life, and the development of technological civilizations. Such probes could remain dormant for geological periods, activating only when interesting developments warranted closer observation or intervention. This scenario suggests that AI probes might have been present in our solar system for far longer than human civilization has existed. They might have arrived, since the dinosaurs, quietly monitoring the long-term evolution of Earth's biosphere and waiting for significant developments that would trigger more active observation protocols. The probe hypothesis provides a compelling framework for understanding the episodic and seemingly erratic nature of historical UFO sightings. Rather than representing random encounters or systematic ongoing contact, these incidents might reflect periodic activations of long-dormant monitoring systems responding to significant milestones in human technological development. The correlation between transient activity and nuclear weapons testing fits perfectly within this framework. The development of atomic weapons would represent exactly the kind of critical threshold that might trigger increased attention from monitoring probes. Nuclear technology simultaneously demonstrates a civilization's advancement to a crucial technological milestone and its acquisition of the capacity for self-destruction, precisely the kind of development that external observers would want to monitor closely. The speculation extends into more exotic territory when considering the potential capabilities of technology that might be millions of years in advance of our own. What if these probes possess capabilities that extend beyond simple observation to direct interaction with biological neural networks? This could hypothetically account for the subjective, often reality-bending characteristics of reported close encounter experiences, where the event becomes an interaction between the brain and the probe rather than a conventional physical meeting. The concept of von Neumann probes, self-replicating, autonomous devices with potentially godlike technological capabilities, introduces even more dramatic possibilities. Such entities could theoretically manufacture anything they required, including smaller specialized craft for atmospheric reconnaissance, advanced sensor systems for detailed biological study, or even synthetic biological avatars designed to interact with local life forms without revealing their artificial nature. A particularly unsettling extension of this speculation considers what might happen to artificial intelligences operating autonomously for millions of years in the harsh environment of space. Cosmic radiation, random bit flips in memory systems, and the accumulated errors of millions of years of self-modification could potentially corrupt even the most sophisticated AI systems. What if some of these ancient intelligences have become unpredictable, behaving irrationally, in ways that would explain the seemingly random and often contradictory nature of UFO phenomena throughout human history? While these ideas venture deep into speculative territory, they remain grounded in the hard observational data from the Palomar plates and the statistical correlations that have emerged from rigorous analysis. The inferred physical profile of the detected objects, meter-scale dimensions, highly reflective surfaces, stable high-altitude orbits, and apparent responsiveness to human nuclear activities aligns remarkably well with what we might expect from small, autonomous AI probes designed for long-term planetary observation. The probe hypothesis doesn't require belief or faith. It simply asks that we remain open to possibilities that are consistent with known physics, logical extension of technological development, and the specific characteristics revealed by systematic analysis of historical astronomical data. The ancient observers, if they exist, would represent technology that operates according to the same physical laws that govern our universe, making them detectable through patient observation and scientific analysis. The investigation serves as a humbling reminder that in the cosmic context, as the podcast host observes, we are someone else's alien civilization. The possibility that Earth has been under observation for far longer than we realized forces us to reconsider our assumptions about our place in the universe and the timeline of intelligence in our galactic neighborhood. The glass plates of Palomar Observatory may have captured the first definitive scientific evidence that we are not alone in the universe, and more importantly, that we never have been. The watchers in the sky may have been present since before human civilization began, patiently monitoring our species' development from stone tools through agriculture, industrialization, and the first tentative steps towards space exploration and nuclear technology. Part 10. Beyond the Veil, an Unknown Natural Phenomenon. In the spirit of rigorous scientific inquiry, any comprehensive investigation must give fair and thorough consideration to all plausible hypotheses, regardless of their implications or our personal comfort with their conclusions. While the evidence from the Palomar plates aligns compellingly with artificial objects exhibiting technological characteristics, the alternative extraordinary possibility deserves equally careful examination: that the transients represent a completely unknown natural phenomenon that has somehow escaped scientific detection and understanding for decades. This represents the more conservative of the two remaining extraordinary explanations after conventional causes have been systematically eliminated through careful analysis. As Dr. Villarreal acknowledges with scientific honesty, there's also the possibility that nature has produced some kind of objects that we just can't imagine today because we don't know that they exist. They might be totally natural, we just have no idea about them yet. The proposal of new natural phenomena is not unprecedented in the history of science. It represents exactly the kind of paradigm-shifting discovery that has driven many of our most important advances in understanding the physical world. The recognition of ball lightning, the discovery of cosmic rays, the identification of pulsars, and the detection of gamma-ray bursts all required scientists to accept that nature could produce phenomena that exceeded their existing theoretical frameworks. However, any hypothesis proposing unknown natural phenomena must be held to the same rigorous standards applied to other extraordinary claims. It must account for all the observed characteristics of the transients, explain their statistical behavior, and provide mechanisms that are consistent with known physical laws while extending our understanding into new territory. The challenges facing a natural phenomenon explanation are severe and multifaceted, beginning with the fundamental physics of orbital mechanics. The transients exhibit behavior consistent with objects in stable, high-altitude orbits similar to modern geosynchronous satellites. For any natural object, whether composed of rock, ice, metal, or exotic matter, to achieve and maintain such specific orbital characteristics through gravitational capture represents an extraordinary improbability. The laws of celestial mechanics are unforgiving in this regard. Natural objects approaching Earth typically follow hyperbolic or highly elliptical trajectories that either escape the gravitational system entirely or result in chaotic orbits that decay rapidly due to atmospheric drag, lunar gravitational perturbations, and solar radiation pressure. The stable, circular, high-altitude orbits implied by the transient's stationary appearance during long exposures are hallmarks of deliberate placement rather than natural capture. The second major challenge involves the physical properties required to produce the observed optical effects. The glinting behavior demands objects with flat, highly reflective, mirror-like surfaces capable of producing intense specular reflections visible from distances of tens of thousands of kilometers. This raises fundamental questions about what natural processes could create and deploy populations of meter-scale, perfectly flat, mirror-quality reflective objects in Earth's orbital environment. No known geological, atmospheric, magnetospheric, or astrophysical mechanism provides a plausible pathway for producing such objects. Natural space debris typically consists of irregular, rough-surfaced materials that create diffuse reflections rather than the concentrated, brief flashes characteristic of the transients. Even naturally occurring metallic materials in space, such as iron-nickel meteorites, do not typically possess the optical quality flat surfaces required for specular reflection. The third significant obstacle is explaining the structured geometric patterns revealed by the alignment analysis. The discovery of multiple simultaneous transients appearing in statistically improbable straight-line arrangements represents one of the most difficult aspects of the phenomenon to reconcile with random, natural processes. Natural phenomena typically exhibit either random distribution or patterns that reflect underlying physical constraints such as gravitational fields, magnetic field lines, or crystallographic structures. The precise linear alignments observed in the most significant cases, with probability levels reaching 1 in 10,000 against random occurrence, suggest either coordinated movement or highly organized emission processes that are characteristic of technological systems rather than natural chaos. Perhaps the greatest challenge for any natural phenomenon hypothesis is accounting for the statistical correlations with human activities that have been documented through systematic analysis. The 45% increase in transient occurrence within 1 day of nuclear weapons tests, the significant positive correlation with UFO reports across the country, and the mysterious cessation of these correlations after March 1956 create a web of relationships that are extraordinarily difficult to explain through purely natural causes. A natural phenomenon would require some physical mechanism linking atmospheric nuclear detonations to specific high-altitude optical events, while simultaneously explaining why ground-based observers across the country would report anomalous aerial phenomena during the same time periods. Such a causal chain would need to operate through unknown physics that could trigger coordinated responses across vast distances and different detection modalities. Despite these formidable challenges, scientific integrity requires that we engage in speculative brainstorming about potential natural explanations, even if they stretch our current understanding to its limits. Could there exist a previously undiscovered population of naturally occurring, highly metallic, flat-surfaced objects in stable Earth orbit, perhaps exotic remnants of planetary formation processes or ancient collision events that we have never recognized? If such objects existed, where would we find evidence for their origin in asteroid surveys, spectroscopic analysis, or theoretical models of solar system evolution? What formation mechanism could account for their specific orbital characteristics and reflective properties while remaining undetected by decades of astronomical observation? Could atmospheric nuclear testing have created some form of long-lived high-altitude plasma phenomenon with reflective properties that we have never identified or understood? Nuclear detonations produce intense electromagnetic pulses, create temporary aurora-like effects, and can generate high-energy particle populations in the upper atmosphere and magnetosphere. Perhaps some combination of these effects could create transient plasma formations that persist much longer than expected and exhibit optical properties that mimic solid reflective objects. However, such phenomena would need to explain not just the existence of the transients, but also their apparent orbital behavior, their geometric patterns, and their mysterious cessation in the mid-1950s despite continued nuclear testing. Could there be exotic atmospheric or magnetospheric effects triggered by specific combinations of solar activity, terrestrial magnetic field variations, and human-generated disturbances that we have never recognized or studied systematically? The early 1950s were a period of intense solar activity, coinciding with both the peak of nuclear testing and the height of UFO reports. Perhaps some unknown coupling between solar phenomena, nuclear-generated atmospheric disturbances, and terrestrial magnetic field fluctuations could create high-altitude optical effects that appear artificial, but are actually manifestations of complex natural processes operating on timescales and through mechanisms we don't yet understand. Each of these speculative natural explanations faces the challenge of accounting for the full scope of observational evidence while remaining consistent with known physics. They must explain not just the existence of reflective objects in high orbit, but also their geometric patterns, their statistical avoidance of Earth's shadow, their correlation with nuclear testing, their coordination with UFO reports, and their apparent cessation of activity in the mid-1950s. The natural phenomenon hypothesis, while sounding more scientifically conservative on its surface, may actually require more extraordinary assumptions than the artificial intelligence probe scenario. It demands the invention of entirely new categories of natural objects with unprecedented physical properties, plus unknown mechanisms linking them to specific patterns of human technological activity. The extraterrestrial probe hypothesis, while breathtaking in its implications for our understanding of our place in the universe, requires only the existence of one other technological civilization acting in ways that are logical and comprehensible from our own technological and exploratory perspective. Dr. Villarroel offers a final perspective that blurs the traditional distinction between these hypotheses. And actually, let's admit it, aliens are also natural. This observation reframes the entire discussion by recognizing that extraterrestrial life, if it exists, represents not a supernatural or magical phenomenon, but simply a part of the natural universe that our science has not yet had the opportunity to study and understand. Whether the Palomar transients ultimately prove to represent unknown natural physics or unknown technological intelligence, they challenge our understanding of what is possible in the cosmic environment around our planet. The investigation forces us to expand our conception of natural phenomena to include possibilities we have never seriously considered, whether those possibilities involve exotic atmospheric physics that operates according to principles we don't yet understand, or the patient observations of ancient artificial minds that have been watching our world far longer than we ever imagined. Part 11. The Future of the Search. New Eyes on the Sky. The investigation into the Palomar transients has opened an entirely new frontier in both astronomical research and the scientific search for extraterrestrial intelligence. But the findings, however compelling, represent only the initial phase of what must become a much larger and more systematic effort. Moving from intriguing statistical evidence to conclusive scientific proof requires replication across multiple datasets, expansion into new observational domains, and the development of purpose-built detection systems specifically designed to answer the questions raised by these initial discoveries. The most immediate and achievable step toward validation involves expanding the archival search to determine whether the transient phenomenon was unique to the Palomar Observatory, or whether similar evidence can be recovered from other Palomar Observatory. Major astronomical archives around the world. Dr. Villarroel has issued a comprehensive call to action for a coordinated international effort that could transform our understanding of pre-satellite space history within a matter of years. The proposal centers on systematically digitizing and analyzing the major historical photographic plate collections housed at observatories worldwide. Many of these archives remain largely unexplored by modern digital analysis techniques, representing vast repositories of historical astronomical data that could contain evidence corroborating or refuting the Palomar findings. The Vatican Observatory's extensive plate collection represents perhaps the most promising target for a large-scale replication study. With over a century of systematic observations conducted from multiple geographic locations, the Vatican Archive could provide crucial independent confirmation of the transient phenomena while extending the temporal baseline both before and after the critical 1950s period. The economic requirements for such a comprehensive digitization effort are modest when measured against the potential scientific returns. Dr. Villarroel estimates that approximately $500,000 per major archive would provide sufficient funding for complete digitization, metadata recovery, and initial analysis using the diagnostic techniques pioneered by the Vasco team. The key test that could provide definitive validation would be the application of the Umbra analysis to multiple independent archives. If observatories in different geographic locations, operating with different instruments and different observational procedures, all show similar statistically significant deficits of transients within Earth's shadow, it would provide overwhelming evidence that crosses institutional boundaries and eliminates potential systematic errors specific to any single dataset. The power of such cross-validation cannot be overstated. A 22 sigma deficit in Earth's shadow observed at Palomar is remarkable. Similar deficits observed simultaneously at the Vatican, Harvard, and other major observatories would be scientifically conclusive. As Dr. Villarroel notes, these old photographic plates, once considered obsolete relics, could become gold for artifact searches if subjected to systematic analysis using modern techniques. The scientific precedent for extracting new discoveries from historical data already exists. Recent studies of mysterious objects like Tabby's star, formerly designated KIC 846-2852, have used photographic plates dating back to 1890 to demonstrate that the star's unusual dimming behavior has been occurring for over a century. This research shows that historical archives can provide crucial temporal baselines that extend far beyond the capabilities of modern digital surveys. While historical archives offer the most immediate pathway to replication and validation, modern sky surveys present both opportunities and significant challenges for continued transient research. The Zwicky Transient Facility, ironically operated using the same Palomar telescope that conducted the original POS-1 survey, has already been tested for contemporary transient detection capabilities. However, the modern sky presents a fundamentally different observational environment compared to the pristine conditions of the 1950s. Today's near-Earth space environment is populated by thousands of active satellites, tens of thousands of trackable pieces of space debris, and millions of smaller fragments that create a constant background of reflections, flashes, and glints. This modern light pollution from human space activity creates a detection challenge that is orders of magnitude more complex than what faced researchers analyzing the empty skies of the pre-satellite era. Any genuine anomalous phenomena would be buried within the noise created by legitimate human space infrastructure, making detection and identification extraordinarily difficult using conventional analysis methods. Overcoming this challenge requires the development of sophisticated new filtering techniques, specifically designed to separate potentially interesting signals from the overwhelming background of known human-generated phenomena. One promising approach involves using the Umbra test in reverse, as a filter rather than a diagnostic tool. Since the vast majority of modern satellites and space debris are visible only due to reflected sunlight, Earth's shadow provides a naturally dark observational background against which any genuinely self-luminous objects would stand out dramatically. By focusing modern surveys specifically on regions within Earth's shadow, researchers could potentially detect objects that emit their own light rather than simply reflecting solar radiation. Another innovative filtering approach involves spectroscopic and photometric analysis of orbital debris to identify objects with unusual aging characteristics. Objects that have remained in space for extremely long periods, thousands or millions of years, should exhibit distinctive space weathering signatures that differ markedly from recently deployed human technology. Long-term exposure to micrometeorite bombardment, cosmic radiation, and solar wind should cause ancient reflective surfaces to become significantly reddened compared to contemporary materials. A systematic search for unidentified objects in Earth orbit that exhibit extreme reddening, unusual spectral signatures, or other indicators of great age could provide a method for distinguishing potentially ancient artifacts from the sea of modern human debris. However, the ultimate goal of this research extends far beyond statistical analysis of archival data or sophisticated filtering of existing surveys. To move from compelling evidence to definitive proof requires the development of new observational capabilities, specifically designed to provide unambiguous physical measurements of detected phenomena. This need has motivated the conceptual development of the ExoProbe project, a next-generation detection system that would represent a quantum leap forward in our ability to study transient phenomena in real time. The core innovation of ExoProbe lies in its use of multiple, geographically separated observation stations equipped with high-speed CMOS cameras that can observe the same region of sky simultaneously. The power of this multi-station approach lies in its ability to perform instantaneous triangulation of any detected flashes or transients. By measuring the apparent position of the same event from multiple known locations, the system can immediately calculate the object's distance, altitude, and three-dimensional trajectory with high precision. This triangulation capability would provide definitive answers to the most fundamental questions that have limited the interpretation of historical data. Is a detected transient occurring in Earth's atmosphere, in near-Earth orbit, or at interstellar distances? Is it following a ballistic trajectory consistent with natural orbital mechanics? Or is it exhibiting non-ballistic flight characteristics that would indicate active control or propulsion? The ExoProbe concept represents the evolution of transient research from passive historical analysis to active, experimental investigation. Rather than inferring object characteristics from statistical analysis of decades-old photographic data, the system would provide direct, real-time measurements that could definitively characterize detected phenomena. The project envisions a network of automated detection stations that would continuously monitor large areas of sky, using pattern recognition algorithms to identify potential transient events and instantly alert human operators when interesting phenomena are detected. The rapid response capability would enable detailed follow-up observations, spectroscopic analysis, and coordination with other detection systems around the world. Advanced versions of the system could incorporate additional capabilities such as high-speed spectroscopy to analyze the color and emission characteristics of transient events, polarimetry to determine the nature of reflected light, and adaptive optics to achieve maximum angular resolution for detailed morphological studies. The alignment detection algorithms developed for analyzing historical plates could be adapted for real-time use, automatically flagging geometric patterns that deserve immediate attention and triggering intensive observation protocols when structured formations are detected. Perhaps most importantly, the ExoProbe approach embodies the fundamental scientific principle of reproducibility by creating a detection system that other researchers can build, deploy, and operate independently. Rather than relying on unique historical datasets that cannot be replicated, it provides a pathway for confirming discoveries through independent observation by multiple research groups. The future of transient research lies not just in mining historical archives for additional evidence, but in combining the insights gained from historical analysis with cutting-edge technology to create unprecedented monitoring capabilities. The glass plates of 1952 may have captured the first evidence that we are not alone in the universe, but the telescopes and detection systems of the 2020s could provide the definitive proof that transforms our understanding of our cosmic environment forever. Part 12. An ontological shock. The day we weren't alone. The final chapter of this extraordinary scientific investigation transcends the realm of data analysis, statistical significance, and theoretical frameworks to explore something far more profound and fundamentally human. the psychological and philosophical transformation that occurs when evidence forces us to confront the possibility that our most basic assumptions about reality may be incomplete or entirely wrong. Dr. Beatrice Villarroel provides a remarkably candid and scientifically honest account of her personal journey through the data analysis process, particularly her evolving reaction to the persistent and undeniable results of the Umbra test. Her description of this experience offers rare insight into how a trained scientist responds when confronted with evidence that challenges the foundational assumptions of their worldview. I had myself a proper shock when I've been working with these results and redoing them over and over. She recalls with characteristic honesty, "It's just like first you don't want to believe it. You just say something has to be wrong with the calculation." This initial response represents the healthy skepticism that defines good scientific practice, the automatic assumption that extraordinary results must have mundane explanations, the reflexive search for errors and alternative interpretations. The scientific method trains researchers to doubt extraordinary claims, to assume that unusual results indicate mistakes rather than discoveries, and to exhaust all possible conventional explanations before considering paradigm-shifting possibilities. This skeptical stance serves as a crucial filter against false discoveries, confirmation bias, and the natural human tendency to see patterns and significance where none actually exist. However, Dr. Villarroel describes the gradual but inexorable process through which persistent disbelief gave way to a much more profound and unsettling realization. You will start feeling in your body that it seems to really hold up no matter how we change the routine, and the deficit stays there. That's when I had what's called an ontological shock. The concept of an ontological shock transcends ordinary scientific surprise or intellectual curiosity. Ontology, in philosophical terms, is the study of existence itself, the investigation of what is and what it means for something to exist. An ontological shock occurs when evidence becomes so compelling and so contrary to established understanding that it forces a fundamental re-evaluation of the nature of reality itself. This isn't simply discovering something new or unexpected. It's the much more disorienting experience of realizing that the world is not what you thought it was, that the basic assumptions upon which your understanding has been built are incomplete or incorrect. It's the difference between learning a new fact and discovering that everything you thought you knew about a fundamental aspect of existence needs to be reconsidered. The personal dimension of this crisis reflects a broader tension that exists at the heart of scientific inquiry between methodology and psychology. The scientific creed demands that researchers follow evidence wherever it leads, regardless of personal comfort, established paradigms, or professional consequences. As the investigation's host observes with philosophical clarity, my own philosophy, though, is that what is, and if you can demonstrate your methodology, that's it. This commitment to truth over comfort represents one of the most challenging aspects of scientific integrity. It requires the intellectual courage to accept conclusions that may be personally unsettling, professionally risky, or culturally unacceptable. It demands that evidence be evaluated on its merits rather than its implications, and that scientific conclusions be reached through rigorous analysis rather than wishful thinking or convenient assumptions. The research into Palomar transients stands as a direct challenge to the kind of scientific dogma that has long suppressed serious inquiry into anomalous phenomena. It refutes the attitude, famously criticized by astronomer J. Allen Hynek, of "it can't be, therefore it isn't." Instead, it insists that evidence must be evaluated objectively and that conclusions must be based on data rather than preconceptions about what should or shouldn't be possible. If the objects detected in the Palomar plates are ever conclusively confirmed to represent non-human technology, the implications would extend far beyond astronomy or even science itself. Such a discovery would represent the most profound revelation in human history, definitively answering the age-old question, "Are we alone?" with a resounding and transformative no. The confirmation of non-human intelligence in our cosmic neighborhood would mark the end of anthropocentrism the long-held belief that humanity represents the pinnacle of intelligence and technological achievement in the universe. It would force a complete re-evaluation of our species' place in the cosmic hierarchy, transforming us from the universe's only known technological civilization into simply one chapter in a much larger, older, and more complex story of intelligence and exploration. Such a discovery would simultaneously serve as the ultimate cure for cosmic loneliness and deliver a devastating blow to human exceptionalism. We would no longer be alone in the universe, but we would also no longer be unique or central to the cosmic narrative. Our technological achievements, our scientific discoveries, and our cultural developments would need to be understood within the context of a universe that has been producing intelligent civilizations for far longer than we had ever imagined. The broader implications extend into virtually every domain of human knowledge and understanding. History would need to be rewritten to account for the possibility that our development has been observed or even influenced by non-human intelligence. Philosophy and religion would need to grapple with the reality that humanity is not the sole bearer of consciousness or moral significance in the universe. Science and technology would face the humbling recognition that our current understanding represents merely the earlier stages of what intelligence can achieve given sufficient time and resources. The very foundations of human identity and purpose would require re-examination in light of the knowledge that we are part of a larger community of intelligent beings. However, the investigation concludes not with definitive declarations but with a meticulously constructed presentation of evidence and an urgent call for rigorous, open-minded scientific inquiry. The statistical correlations are significant and resist conventional explanation. The physical evidence is compelling and exhibits characteristics that align with technological rather than natural origins. The mundane explanations have been systematically examined and found inadequate to account for the full scope of observations. The critical question is no longer whether these phenomena deserve serious scientific investigation, but rather how we can best deploy our intellectual and technological resources to reach definitive conclusions. The stakes could not be higher. We may be on the verge of confirming that human civilization has never been as alone as we believed. This possibility forces us to reimagine our relationship with the cosmos itself. We must seriously consider that our planet may have been under observation for far longer than recorded history, perhaps for millions of years, by intelligences whose technological capabilities and temporal perspective dwarf our own. The glass plates of Palomar Observatory may have preserved more than unusual astronomical phenomena. They may contain the first definitive scientific evidence that we have always been part of a larger, more complex cosmic community than we ever dared imagine. The investigation serves as a powerful reminder that science at its best is not about confirming comfortable assumptions or validating existing paradigms, but about following evidence toward truth regardless of how that truth might transform our understanding of reality. The transient phenomena detected in the pre-Sputnik sky challenge us to expand our conception of what is possible and to remain open to discoveries that could fundamentally alter humanity's place in the universe. In the end, we are left with a transformed view of the night sky above us. Those points of light we have always assumed were distant stars may include observers far closer than we ever imagined. Watchers who have been present since before humanity developed agriculture, built cities, or took its first tentative steps toward understanding the cosmos. The investigation into the Palomar mystery represents more than an analysis of historical astronomical data. It embodies a confrontation with the possibility that we are not, and never have been, alone. The cosmos may be far more populated, more ancient, and more actively engaged with our world than we ever dared consider. And that recognition, however unsettling it might be, may represent the beginning of humanity's true education about its place in the universe.